question 2, we've got a particle moving along and it's going to receive an impulse but at an angle. I've just redrawn the diagram here, as this is just how I like to have mine drawn. Also, this means I can work out that this angle that I've shaded, that's alpha, whereas the whole angle that I gave you is 90 plus alpha. In case it helps me later on, this means I can now see what we've got here. So we're told tan alpha is 3/4, and in case it's going to be useful, I can very quickly from that's opposite over adjacent, work out that side. So that's going to give me sine alpha and cos alpha. Not sure if I'm going to need those later, but it's always a handy thing for me to work out. Right, we want to find the speed of this particle B immediately after the impulse and its direction of motion. And actually we'll probably find both those things out at the same time. What do we also know? We know the mass is 0.25 kilograms in the question. Okay. Right. So what we're going to look at, I'm going to first of all define which way I think this particle is going to be going afterwards, and what I'm going to do is I'm going to resolve in 2 directions. So I'm going to define my velocity afterwards as 2 components. So I'm going to say V1 is the velocity along the line on which it was initially moving, and V2 is going to be the component velocity perpendicular to where it was initially moving. So now I can look at the 2 ways. So along the line of motion, I can use the impulse is the change in momentum. Now, if you look at my diagram, you've got to decide which way you're going to say is positive. So I'm going to say that moving from right to left is positive direction for my velocity. Right, so the impulse in that direction along the line is going to be, I'm resolving this way on my diagram where the red line is. So I want to resolve this way, so that's going to be opposite angle alpha. So the component in that direction is the magnitude sine alpha. The mass is 0.25. The final velocity is my V1, which is going to be positive because that's the direction I've defined it. I'm going to subtract my initial velocity. Now my initial velocity is going in what I've called the negative direction. Right, I can now substitute in what I found earlier for sine alpha. 12.5 times 3 divided by 5 is 30. And then divided by a quarter, which gives me 30 is V1 plus 30. So that means my V1 was actually 0. Right, now we're going to resolve in the other direction, so we're going to resolve perpendicular to the initial motion. And we're going to do the same thing again with the impulse. So now I'm resolving this way. So that component is going to be 12.5 cos alpha. Same thing again, so the mass is 0.25. My final velocity here, well, I'm defining up as positive, so that's V2, and my initial velocity was 0, there was nothing in that direction. I can then rearrange that to find that V2 is 40. So afterwards, I've actually got 40 and 0 as my components, which means I can now answer both these questions at the same time. It's 40 meters per second and perpendicular to the initial line of motion. Or straight up in the same direction as the impulse.